So I'm Camiel Weijenberg. I am CEO of Digital. Can everyone see my screen?
Yes, it's good.
Yeah.
Yep.
So I'm Camiel Weijenberg. I'm Dutch. I'm the CEO of Digital Blue Foam, and is a tech company for the AEC that we started 4 years ago, and we launched the business almost 2 years ago, where we help our clients develop sites with our online tools. So everybody can now actually log in and you can analyze your site, as you can see here on screen, which is our platform. You can analyze sustainability issues such as solar, main wind directions. You can get a 3D context. While you're doing that, you can design buildings or a smaller building or even urban districts all around data. And we are very much data driven in terms of assisting our customers to make decisions based on data. I'll take you through a short presentation and then I'll do a quick demo. And I think we'll do the Q&A later, correct?
That's right, Camiel. Go ahead.
Super. So how do we leverage innovation and rethink place and process and face new challenges? So this is one of our core questions, right, in our Digital Blue Foam business. How to embrace innovation and rethink how we work in architecture and building industry design. So the next 20 years, as most of you know, 2 billion people will be moving to an urban environment. They all need to work, live life, right? So they need to shop, work, do their entertainment, etc. That is a lot of city that needs to be developed. It also needs to be developed in a more sustainable way. As you all probably know, 39% of global CO2 emissions are coming from the AEC industry, which is ridiculous and it needs to change. We have about 10 years left according to the UN, and the way we are developing now is not a sustainable way yet. Since it's not 1982, and some of you might question why 1982. 1982 is when, probably shouldn't mention any names, but certain CAD programs were launched, and they were based on using a mouse and a keyboard to draw lines. We still work like that predominantly in most of the firms. What we're proposing is to work with a responsive solution that is online and where you can compute solutions based on data. So we rely a lot on what the computer can do, and we rely a lot on what the architect and designer want to do. And so we fuse computer generative design with how people work and design in spaces and cities. So I'll just take you through what we do, how we're doing it, and a short story, and our sort of developments and what's next, and do a short demonstration. So our goal is to have fast informed design in a sustainable design from day one. So immediately start designing with this kind of data instead of creating add-ons in the future based on technologies that are typically very expensive. We accept by typically 80%. So our customers save 1 week on a 2 to 3 week project. So we have 5 core principles: geodata in every city globally, a simple to use program that is something you can learn in minutes and you can get advanced in a couple of hours. Cloud compute projects. So like we're saying, we are based online, so we use cloud computing for more complex things that are typically quite difficult to do on a desktop. We use a lot of analytical tools to advance and improve projects. Like I said, we're fully web-based. You don't need to install anything for our main platform. So 50% of our customers save 1 week on a 2 to 3 week project. So it also allows our customers to work on more projects in the same amount of time, and therefore become maybe more successful in their endeavor. This is our core team. We are 8 people at the moment, and we're based in 6 different countries. So we've really embraced the digital way of working and scouting for talent globally. So like I said, it's not 1982. We need to embrace and transform how we work in the AEC industry. Use data, we need to improve productivity, and we need to improve sustainability. So our goal is to accelerate world's transition to creating better cities and better buildings based on data and sustainability. Why digital blue foam? So as some of you might know, blue foam is a typical massing modeling material to make quick studies of a building or an urban district. We brought this process online, and therefore we call it digital blue foam. But we want to keep it as intuitive and simple. So from our core values, we believe in 6 sort of drivers: world's data, easy to learn, design automation, augmented intelligence, which means we use the best of computers and the best of people, and we fuse that in our platform. Sustainability first, and of course, we've built a pipeline towards existing BIM programs, either through the IFC or directly a pipeline into ArchiCAD. So some of the key features, I'll show you here quickly, and I'll show you in our demo. So we visualize historical weather data from the last 10 years, and then we average that out and show these typical maps, as you can see on the right side of my screen. And then we calculate heuristic solar radiation with that. So here you can see an example of that radiation. And you can calculate during different types of the year to see how your building configuration might be affected. We also generate a facade condition in relation to program and site. So instantly a facade option is generated by our program. Of course, you can then manipulate and change it as you like further. So there's some of the key shots from our tool. On the left, you see this heuristic site, as well as the solar and terrain modeling that is generated on our platform. On the top right, you can see a more detailed model. So we can also work with external data for some of the sites and locations. And we have a sort of heat map to show where there are very popular restaurants, very popular hotels, etc. To maybe help you determine a certain walkway or entrance point for your building. Again, all we want to do is bring data to the design process and assist designers. We also work with some of the sort of main file exchanges, so you can bring in your own constraints for the site and work with limitations that are based in planning. So you can have a certain setback in an angle or height limitations, and the tool will show immediately if you are in or outside, and you can therefore make instant adjustments to your building, and that will reflect in then your GFA and all the Excel sheets that come out of that. So one thing we're really proud of is this sort of pen tool where you can mark your site and it will draw the buildings, or it will draw a road, and of course different conditions and information can be given to that. We've got quite a fun sort of imaginative tool. So on the left you can see this sort of beatbox mixing for your music station, and we actually is an input from one of our clients, and we've taken this challenge on, and we made this sort of mixing board where you see these different shapes of squares, the C, and these different letters. So these can be marked on the site. So it will populate the site according to your GFA and which typology you highlight. You can then offset the building, and you can offset cantilevers in terms of shifting the building or having a side offset. So it's quite a fun and intuitive way of exploring different types of building typologies for your site, and maybe to discuss with your client or just with your team and see what you think is a potential solution. Like I mentioned earlier, we've built a pipeline to existing workflows. So we're very strong in these programs where we build an Excel sheet directly from our tool that you can download. You can go to SketchUp. You can, of course, go to Rhino, and you can also go to Grasshopper, but not necessary. And you can go directly to ArchiCAD. Inside our tool is a way that you can maybe test your site and show different types of options and compare them on different efficiencies or what kind of program you have in the site.
Hi, Camiel. We can't seems to hear you. You need to unmute.
Is that since the beginning?
No, no. It just
Just now?
yeah. You can continue.
Okay. Shall I go back a little bit or?
No, from the ArchiCAD. Yeah,
Okay, great. Great. So here in the middle of the screen, you can see the online platform, and on the right, you can see ArchiCAD, and it's sort of syncing the data instantly to ArchiCAD. And these are native components. So floor slab is actually floor slab, facade is facade, etc. So you can manipulate directly. You do not have to redraw it. You can if you want, of course, but you don't have to. And if you want to try a different option and bring that into ArchiCAD, you can resync it and it will come in again. You can just see it rebuilding the model. And there you go again. So what we're really trying to do is make the design process obviously more, a lot more fast, but also well informed. So people make decisions on data and can quickly test these with their team and just see how that sort of can evolve for the site. So we have a very sort of hands-on way of working with our clients. So we have clients in an enterprise account where we work with them on a very agile way of developing the tool further. So we really sit down with the team and say, okay, we have a really big bottleneck in how we work here. How can we address that, and how can we make that easier with digital blue foam? And therefore, we adapt and validate very quickly in a 2-week cycle. So it's not every year or every 2 years that there's an update. There's typically an update in our software every 2 weeks to 4 weeks, depending on what we are launching next, of course. So we believe agile is evolution. So 2017 top left model is our sort of initial base test model where you can see the sort of little nodes that you can drag and move. And then we start working with regulation and setbacks. And then you can see in the bottom middle, bottom left are sort of our latest tool developments. We've actually sort of honing in on this more and more and more. And you can see that we've now got a really mature tool. And actually everyone can sign up and try, of course, the tool for, I think it's currently 88 US dollar a month, and you can go to any site, download unlimited amount of information. So it's actually a really exciting point to maybe try the tool or sign up or just see what we're doing with the blue foam. So again, we believe agile is evolution, and therefore we update a lot. We try a lot of things. So we try to be very communicative with our sort of community and hear what they say and things that they think are successful. So we try a lot of different things and we evolve quite quickly from that. So I'll do a short demonstration. I had it open, but let me check. Yeah, there we go. So this is our landing page after you've logged in, and you can just type in maybe a location and click enter. Just quick tips, but so maybe here is quite a good site. So I'm on my laptop. Okay, so let's click on this site. And okay, actually I want to edit it a little bit. So I'll just go edit. I change it maybe a little bit. And maybe I want to move this one out. So I say, okay, let's confirm. Let's save that. Okay. And it will load the site. So we start bringing all this data in our native environment. So obviously I'm familiar with the tool. So here you can see it's a top view of the site and it has built this in a 3D environment. And you can say, well, maybe we want something quite high and dense, just like our neighboring buildings. I want to maybe keep it very simple. I just want to have some straight straight blocks, maybe an L shape. I'm okay with the offset, and then I just click run. And for now, I'll just take a nominal area of the site. And she said, well, actually there's a little road across, so maybe I want to draw through that, right? And maybe another one just here. And then I click check again how that comes out. Maybe make this 6. And then we'll start to generate more options from that. Right. It is doing it. I'm not entirely sure why it's so slow. Maybe because I'm in a call at the same time. Maybe I'll stop that. As you see, it's quite a large site, but maybe I'll just show you how these wind directions work. So here we can see how that wind comes through on a 10-year average. You can also just see how the sun maybe develops. In Singapore, of course, it's quite typical year-round. But if you go more northern or southern part of the hemisphere, it's of course much more angular, and you can work out your shadow casting from that, as you can see, is developing for. And of course, if you click on the sun, you can change these dates quite simple. So if you maybe want to go to January, it will update that and it'll run again. So let me just try this site again. So you see it starts splitting the buildings, and actually you can then just save your options. Maybe try more. Actually, I don't think this line is very successful, so maybe I'll just remove that. Maybe you want to try another one, right? Let's say you want to have more in this direction. And maybe I want to have a park there. So we'll generate accordingly. So you see, maybe you want to save this one as well. I quite like that. So it's a very playful tool, and so maybe I want to have this one, I want this building a lot higher. So instead of maybe 2, I make it 15 stories, and I make it residential. I can change the floor height to 3.8, submit. Oh, I clicked plus by accident. So actually with your arrows, you can rotate the block, or you can scale it. And you can rotate it with left and right. And so maybe I want to save this one as well. So maybe if you tried a couple of options, I'm going to shift this one a little bit in. Maybe I want this to be leisure. and on a very high floor to ceiling. So I would like to say that. So then once you have these, you can say, okay, you've got 5 options. I can maybe want to have a quick compare of how they're performing and what areas are in them. So here you can see that these are the sort of the typical sites that you've just created. And from there on, you can go back to the tool maybe, and you can manipulate them further. So you can just click on them and it will reset it. So you can maybe make this 7 stories and submit. So we could try to create a very intuitive tool, and then here you can see the download buttons and upload buttons, and synchronization if you have ArchiCAD open. And then here's some options for turning on trees, and here's some drawings of plan sections and all that you can derive from the site. And then here are some layers and urban information that you can turn on. That is nice to see here. Yeah, sorry, my internet connection seems a bit slow with the meeting on at the same time. But I think that gives a very good overview of what we're doing. And again, we always look for our feedback from customers and improving, but we're very confident in this tool, and everybody can try the tool and sign up just by going to digitalbluefoam.com. And I have a few more slides left, I think. Actually, we only have 5 more minutes left, so maybe we can do a few questions and answers, or people can type in the.
Yeah. So how this going to be, Camiel? Maybe towards the end, then people will just consolidate if they have any question for you.
Sure.
Thank you.
Okay.
So you, I guess, it's the end of your presentation, right?
Yeah.
Thanks. Thank you, Camiel, for your presentation. I think it's been very informative and wonderful to see how does this. And I have a question for you. I think let's wait till the end of the session on the Q&A session.
Okay.
Thank you.
Great. Thank you very much.
Thanks, Camiel.
Thanks, everyone. Thank you.
Okay, next, can I invite the next speaker to join us and present? That would be Marleen.
Yeah, Marleen.
Veryasian, right, Marleen?
Yeah, Weijenberg and the Veryasian. Marleen is actually a partner at our design firm.
All right, fantastic. Marleen, you can try to share your screen, and I'll stop presenting for now.
Do you hear us?
Yes.
Yes? Okay. Good.
All good?
Wait, we have a problem with sharing. We come back to you ASAP, 1 minute.
Sure.
Starting up our laptop.
I hope everyone can be a little bit patient today. And anyway, it's Friday, so we're having a little bit of problem here.
One moment and it's okay.
It's okay. Right, all good. We can see your screen now.
You can see our screen?
Yes, we can.
Okay, good.
You may start whenever you are ready.
Share from this one. Okay.
Right. You may start.
Welcome all.
Thank you. Go ahead.
Welcome all. We are from Weijenberg. My name is Marleen INIA. Next to me is Zaki Fatis. We are an award-winning design studio in Singapore with very close ties to Amsterdam and Jakarta. From origin, we are all architects, and we develop or renovate architectural and interior design projects. Human designs with a deep understanding and a social and natural world. At the same time, we try to embrace technologies. We strive to tackle new challenges in our changing society and drive for solutions to build a better tomorrow. A lot of our projects are within hospitality, so F&B, bars, restaurants, lounges, but also a big demand is coming from our so-called feature projects, special objects to be designed with latest technologies and insights. For the rest, we do residential, commercial work, and as designers, we're open for all challenges, so the range is quite broad. Crafting the traditional, shaping the future is our firm's philosophy. And this means a lot. It captures almost everything what we like to be, what we like to carry out. Without a past, there's no future. Without a past, we can't invent a future. We need the past to make the future happen. We need our knowledge from the past to develop the future. The past gives meaning to the future, socially and emotionally, which is a very important aspect. So we should never neglect the past, since then the future would be empty. And so we can go on and on and on. Design is more about shapes and forms. It's more than a choice of just materials and structures. Design is about what we think is about being a change maker. We're striving to create best to get the best out of people. We try to create a space that enhance our human beings, where we live and where we work the best. It gets the best out of us. Design can evoke interaction, it can evoke imagination, it can be critical. So design is way more than just some nice colors and some nice material all put together. I think as designers we should, and we are obliged almost, to help this world to a better future. Of course, details are incredibly important and show the way we care about our design and about everything, which is incredibly important. As said, crafting the traditional, shaping the future. Without knowing the past, the tradition and the traditional craftsmanship, we can never get a human future digital world or a human future world. We really strongly believe that we need to merge this cultural heritage with latest digital developments. This makes sense to the digitalization. This gives depth to every design we develop. This gives meaning to every project. So we always try to seek for collaboration with traditional technologies, with local materials, with local manufacturers, but always striving to get the most out of the modern technologies. The combination of these two is really our firm's philosophy, and we try to carry it out, or we carry it out in every project we do. Local and globally, you can take this very literally. We do local projects and global projects. Yes, that's true. Basically, we're everywhere. But it also goes back to local tradition with global development. Basically, it's all about the same philosophy, crafting the tradition, shaping the future. It also means local projects. It means also capturing of skill, local conditions, and in the same time striving to use global knowledge. It goes about local and global. At the same time, locally we can have small, medium, large projects, but also globally we can have small, medium, large projects. Small doesn't mean simple. Large doesn't mean complex straight away. It can mean complex. Small can mean simple, but it has nothing to do with that. Every project or every new challenge, we try to tackle the same, and we try to seek behind simple solutions to really to add something to our environment. Some examples of our project. This is Raw, a restaurant done in Taiwan. Later on, we will tell you a bit more about production and about the way we design. This is beautiful, made of wood, digitally crafted. Another object. This was for a project here locally in Singapore for a memorial museum. Also same, you can see here, crafting a traditional, shaping the future. Without the digital world, we could have never designed this one, but we still tackling back to the past. Another example of facade made with the latest technologies, and an example of our residential work. Please visit our website, www.weijenberg.co, for any more information about the work we do. And for any questions, you can reach us. I'd like to give now the word to Zach. It's our lead designer in the firm, and he's really the specialist about digital fabrication, digital designing, parametric design, etc.
Okay. Yeah, thanks, Marleen. So in here, I just want to go through our project quickly, and I would like to explain like how we design, how the process behind it. So this one is it's called China 500. We designed for online betting company in China, and they came to us and they asked us to design a lobby in their office. So because of we think about the flow that coming from company's profile, we try to analyzing wind currents and turning them into shape and pattern. Basically using parametric tools like Rhino Grasshopper to design, but not only for the design, but also thinking further. We use this technology to prepare for the manufacturing. So this one is quite fast project. So we design in Singapore, and we send all of the information of all of the production data to the China factory, and they source the local material and etc. And they produce the sample and make the the object. So because of this location is on the 15th floor, if I'm not wrong. So we have to think about how to bring this object to the up. Yeah. So we make it part the object. We slice it so it fits into the lift. And yeah, this is the detail, the small detail that we try to focus on. Also, this is brass inlay on the wood. You see here, it's like how two parts is joined together. So how this works, basically, we glue together like small block of wood and we CNC, and after that we like smoothing with doing like a robotic arms and manual worker. So yeah, this one of the part in the workshop before they like installing. This is also the detail. So from block of wood, we also try to manage the exact location for the inlay that you see here, and then put all of the information to the fabrication, and they will like fabricate it. As I mentioned before, the idea is try to capturing the flow of the wind and how the the money come and go. So we try to also design the floor infill layout. So each floor, its style is really different pattern. So we try to we try to design that. We try to help the fabricator like to fabricate this with exact design. After finish that project, the clients very happy and they asked us to also design another office in Hong Kong. This is in Bank of China. The rent price is so high, and they want the project is like all done in at least 3 months. So we like really going into fast pace. We design and send to the workshop, and then they give us a feedback. So this really like back and forth design and refinement. As Marleen mentioned before, like traditional, we try to combine between traditional and future. So yeah, we try to use wood as a main element in here in this office. The idea is like using like the strip wood. We only like simple CNC in part and glue them together, and after that we smooth it. So this part is come into like small part, like 2 meters high, and then wide is only like 1 meter, and then they join together on site. This sample like how they use the robotic arm. Yeah, so we also think the walls not only become like division between one room to the other, but how to integrate with the furniture like seating and so on and so forth. Another project that we did is here is Rao. It's from Michelin chef Andre. So we try to think about how to design the restaurant without partition wall. So we think about the let's say wooden ribbon like driving the dinners like from the entrance to the inside, like, and enjoy the food. So we translate the Chef Andre's cooking philosophy with subtle diffusion using CNC technology, and we try to optimize the wood quantity and waste. So yeah, there's a lot of using in digital technology in here. Yeah, so before we doing the small a big mock-up, we try to design, we try to see the possibility also from the 3D printing, because we can see the overall shape and what is the we can, let's say we can see the limitation, and yeah, we can let's imagine how it looks like. So here that shape is coming from the like small block wood. I think there's like 3 to 5 types of wood glued together, and then after that just like smoothing using like 5-axis CNC. I'll show you the video. So in here we use evolutionary like to get the like minimum amount of wood. This is how the sequence should go. Yeah, so we also think about how to like transport it from the workshop to the restaurant and how to install. So all of the information embedded in one file, and we try to share with the workshop. Yeah, this is how the inside looks like. Okay, so in Weijenberg, we have like a design think tank. It's called Veryasian. Basically, we like driven by curiosity. We try to develop our own research project through collaboration with universities and other knowledge institutions, both in like Singapore or worldwide. I just show you some few samples. Like here, like try to like mainly this is like for small object, but a bit complicated in terms of fabrication. On the left, we try to use like metal bending to create the like continuous like 8-shaped lights, and then on the right we try to use like a bamboo, and we try to bend it bamboo to produce a sitting like chair. And this also the same technique as you saw on the RAW project, with like small block wood, and then we CNC it. This one is like research project. We collaborate with the SUTD. We got a grant from NAMIC. This is we try to 3D print sound absorber. Yeah. First we test like what's the relation basically with form and shape and the sound. Is there any differences between like 2D, 3D shape? From that we get so many variation, like 1,000 more. And then we can see like a different shape effect on different frequencies. after that, we try to come up with like several patterns. So in here we have like 5 patterns with 3 different depth and is in the relation with the sound. So we 3D print all of them and then we test it in SUTD. Yeah, and then we choose like from 9 pattern we take one pattern 9 because it's like working nicely with sound, and the internal part is like connected with the other. Yeah, so here we try to understand what if we change one of the parameters, like let's say aperture, depth, connection, etc. So in this research, we do both like actual experiment, like physical experiment and digital experiment. And then we try to see what is the difference, is the result is correct or not. In here, we try to do in digital simulation. We use Grasshopper in here. So we put all of the information like material information to here. So yeah. And then we try to test like using the 2 techniques to understand how the sounds behave in the meeting room. Yeah, we think about like what if in one small meeting room there's like 6 people, or like speak together, and how the sound wave behave. And then we try to like do another task simulation using ray tracing. We try to make like a base surface, and we subdivide it and doing like a race path simulation. So from that we can see like which area that get the the maximum ray tracing, and then we can eliminate the rest. So in here we test it, and the simulation like running for like 1 day, like more than 1 day, and we got like 10,000 option, and we choose based on the criteria. Yeah, I think that's all from me. If you wanna check more about our project, please go to like www.weijenberg.co, and you can see like our project there. Thank you.
Thanks. Thank you. So another interesting presentation. So next, it's time for Boustead. So maybe Harmeet from Boustead, are you able to share your screen?
Yes, Mr. Khalil.
Thank you. Go ahead.
Yeah, can you see my screen?
Yep. Can you make it present? Yep. Fantastic. So allow me to just start with this presentation. Again, today we are going to share from Boustead project. We are from Boustead project. My name is Khalil. We are going to share on design documentation to fabrication with Dynamo. Yeah, so next, who we are. Myself, Khalil, Senior Digital Delivery Manager for Boustead project. I have myself in my team today, Harmeet, he's a BIM lead in Boustead project, and we have David, is one of the BIM modelers. So today we are going to share with you guys what we do using Dynamo in terms of computational and also visual programming and coding and scripting. Right. Before that, let me just do a quick introduction to who we are and what we are doing. Yes, Boustead project, we established in 1996. We formed part of the real estate solution division of a 190-year-old Boustead Singapore, part of the bigger group. We are qualified builder, developer, BCA grade A1. And yep, maybe the next clip. Let me just change. So this is a video on what we are doing with Boustead. So we have incorporated a digital model into design, into construction. Right. Bear with the. It's a bit slow. I think there's some issue with the connectivity. Operations. Implementation, we use digital model for design and implementation on most of our project. This is a virtual walkthrough. We do a lot of collaboration with digital model, and we identify issue, we track those issues within the digital environment itself. We use all those data for analytics. We have common data environment that we can use collaboratively. AR, VR, right now we are using on most of our project. Augmented reality. It allows people to understand and immerse themselves into the design even before it's being constructed. We have drones. We apply drones to collect point cloud files and also progress update of individual project during construction. We have laser scanning, right? And these point cloud files we use to validate with the digital model of the design or design intent model that we have. We also apply some lean methodology to our construction, where we integrate some of the cost and time to see if there's any impact to the progress and also to the cost itself. Yep, we have digital precast tracking. We use it for building management, digital model. Yeah, of course, I didn't do this all alone. These are the group of people, the good people that we have in the organization who's helping me with all those implementation. And they consist of modelers, BIM coordinators, and they are very young and very hungry for knowledge, if I may say. So I hope this give a taste of you guys what we do here in Boustead. And without further ado, I'm handing over to Mr. Harmeet to share more on Dynamo and how he applied Dynamo. Over to you, Harmeet.
Thank you, Mr. Khalil. Hi, good afternoon. My name is Harmeet. I'm the BIM lead for my project. Okay, so let's start with computational BIM design. Now, what exactly is computational BIM design? We actually use it in our projects or in our organization to help sort of streamline and make our modeling more efficient. So we take some of the we look at some of the pain points and we see how we can speed up the process by eliminating a few steps, and we use computational design for that. Now, one software under computational design that we use is Dynamo, and I'm pretty sure that most of the industry has heard about this term Dynamo. So what Dynamo does is it basically enables a non-programmer or a non-coder scripter to have the ability to do a bit of coding, to eliminate a few of the processes and the steps which are very repetitive. So that's one thing which Boustead has picked up in terms of trying to increase productivity. As you can see over here, Dynamo is just a simple, coherent, and capable program tool enabling users of any proficiency to create and develop scripts and coding for computational design to increase productivity. So we can use it for daily usage to solve technical issues, no matter how small the issues are, or we can use it to create complex building models using algorithms. Okay, so these are some of the use cases that we have in Boustead. We start from just a simple cutting sections when we're working with CSDs or when working on plans. We can also use Dynamo to find headroom clearances for authority requirements. We can use we can create sheets from the views that we have created from the sections, or even if we have other views. For sometimes we work with MEP, we can create pipes or any other MEP services from just by drawing a few lines. We have auto dimensioning, interference checking, fabrication. Then also we have data from the field which we get in a form of Excel or something back into our BIM, which is in Revit. Then also complex massing. So for this presentation, we are just going to look at 4 of these: cutting sections, creating sheet from views, interference, and fabrication. So let's start with cutting sections. Okay. Okay, so basically, the key thing with cutting sections is we need to first we are creating many different steps into 5 smaller steps. So what we're doing is we are going to be just running while we run the script, right? The script goes in and computes all the lines that we have drawn inside. So we just have to draw simple detail lines. Then when we run the script will basically take all these lines. As you can see over here, like when we work with CSD, there's a lot of sections that we can go through with CSD, especially when the architect or the consultants or the clients, they ask for a lot of these sections that need to be cut, because they need to see at every single area where the penetration is, and especially with those which are gravity pipes. So these are one of the painstaking areas that we need to look at. So it's going to cause my modeler or my coordinator to come up with many different sections for just a small area, just a simple room. Now we have sort of streamlined the process into five steps. Basically, the first step is to basically just draw these lines. Okay, when we draw these lines, once the lines are ready, we can then just run the script. So as you can see over here, it's very simple. Just run a script. Then here we indicate our sheet name. We indicate our sheet numbering. We have a title block family. We also have the issue date of the sheet, checked by, designed by. We can also, if we want to place these views on sheets, as well as creating adding templates to these views. So we have streamlined all these processes into just one workflow, which allows us to come up with multiple users. Now, this particular drawing has about 20 sections that we have cut. So first we choose the view template. Then now out of the 20, we choose 8, first 8, then 6, then 6 again. Okay, so we can see on the left over here, we have all our sections which are created. So we have 8, 6, and 6. Now, although it creates some level of automation, I have to be honest, the views that come in, sometimes they do not get placed particularly in the right order. So there is still a bit of moving around that we need to do. But I mean, if we look at it in a bigger picture, in a very holistic picture, is that it sort of streamlined a lot of process. I mean, we got 20 sheets into 3, got 20 views into 3 sheets in a matter of minutes. And that's what we do in Boustead, is we try to optimize productivity, and we are trying to use computational BIM as much as we can into our daily lives. And it gives the ability for the BIM modelers, for the BIM coordinators who have no experience in coding or scripting, to come up with all of these easy and fascinating ways to sort of speed up productivity. And that's what BIM is actually supposed to do in the industry, is to speed up productivity. Then we now, using computational BIM, from this we can actually come up with fabrication. And this is what the industry is now moving on to, 3D fabrication, which is like PBU, or simple, like as you can see in the video in the center, is just modular M&E services. So a lot of stakeholders are now started looking into this kind of fabrication, where they're looking at categories, which is constructability, fabrication, and installation. So when we look at constructability, we are looking at how the module is to be constructed, and how is it easy to be for maintenance in the future. How can we get it into a corridor? How can we build a corridor with the modulation inside? So these are the things that we use computational BIM to try to help us analyze, try to help us understand. Then we look at, once the constructability is down, say for the, you can see in the center image, center video, is we are showing a corridor with 3D fabricated modulations of MEP services. So now we look at how many services can we divide one corridor into, and that's where we look at fabrication. So we then take this information, take the data that we get from this, and then we send it to our subcontractors to develop the fabrication offsite before they bring it to our site. Then we look at installation on site, where each of these modulars have to go up, and then we do precast tracking as well, as you've seen in the video. So we do the tracking for all of these informations to see what is our status at the current point of time. And then it's easy representation for our clients or our architect. It's good visualization. They can understand where the project is today or yesterday or last week, or maybe 2 months from now. What is our projected completion date? Whether we are ahead of time, or we are on time, or we are delayed in time. So this is a very good way for us to understand the project needs and how we can come up with solutions to speed up the process. Next, I would like to hand it over to my colleague, Mr. David, for interference checking. David?
Thanks, Harmeet. Maybe can go back. I'd like to add to what you shared just now. So I think what we like to share here is that I think we have done a coordination model to a certain extent, if you guys have seen. And how do we bring this information to the fabricator? So now the first step is we need to make sure that all these services, as what we showed now, are properly coordinated, and the steel framing are formed with standard length. And this allows each particular modules to be integrated with different multiple trades and discipline in this case. So the next step is these information are shared downstream to the fabricator, where eventually they will use this information for fabrication. And moving ahead, as what Harmeet mentioned just now, some of these elements can be tracked in terms of the status, whether they are still in fabrication or they have been installed on site, in terms of the status of each element that is being fabricated. Yeah, so basically that's how in Boustead we are trying to use data, we are trying to use digital model, and at the same time a modular design. And with Dynamo, where earlier on we discussed about how we can, to a certain extent, create documentation. And the next slides, my colleague David, he will share more on how interference checking can be done, where to a certain extent it relates back to the coordination that we are going to do and tie back to the fabrication. Over to you, David. Thank you so much.
Okay, thanks, Mr. Khalil and Harmeet. Can you guys hear me?
Yes, we can. Go ahead.
Okay.
Thank
So before me presenting on the second half of the presentation, which is the interference checking, let me give you a slight intro about myself. So I'm a BIM modeler in Boustead, and I do have a programming background experience in my study field. So when it comes to interference checking, right, there's a small experience that I went through with having clash detection and everything. So one of them is in the current project that I'm working on is ceiling. So they call me they so-called call me as a ceiling guy. So whatever problems that they have with ceiling when it comes to clash detection or maybe interference check with other elements, they'll come and ask me or highlight to me that there's clashes and everywhere. So in that period of time, I do not have any experience on Dynamo or anything, but I did some research on how to resolve those clashes, which is using external program like Navisworks, and from there you try to import to Navis. Then from there you import back to Revit. So yeah, next slide.
Sorry, David. Maybe if I would like to add to David, again, what we want to share with everyone today, we apply some kind of design thinking. We understand that there is a particular pinpoints. In this case, David himself has identified some of his pinpoints because on the work that he's been assigned, a particular work where ceiling, there's a lot of interference, or if we may say a lot of coordination issue needs to be done. So today he's going to share with you guys how it comes back to his own daily work, how it is going to be applied to his daily work. Yeah, David, over to you. Thank you.
Yeah, thank you. Next. Yeah, so there's two ways of approach that you can do normally, which is through Navisworks, and then or either you can use an external program to run those clashes. So when you try in that both way, right, you can achieve what you want. But as a programmer, for me, I would like to come up with just a one program software which Dynamo is available in Revit. So I tried just using Dynamo to generate those clashes and 3D views. Next. Yeah. So this is the Dynamo script that I came up with. So first thing first, you just run the program and you'll just find for you all the interference check with those two categories. And when those clash detections are being shown, you can color them or override the visibility graphics by adding this green and red color between those two elements, which is same concept as what I've seen from Navisworks, because they always like to show the clash detection with two different elements with two different colors, and in the end generate 3D views separately for each and individual clashes. Next. So yeah, what do we achieve next? First thing first, I just use Dynamo, so there's no other external program needed to run or other plugins. Secondly, yeah, those clashes are identified, but keep in mind it depends on the project file base, means the size of the project file, or either you want to view the clash detection in a specific view. So if you want to view it in a specific view, the clash detection result when you run through Dynamo script, you'll generate within few seconds or minutes. But when it comes to project file, there's a lot of element, a lot of levels involved. It will take kind of long hours to generate. So personal advice, try to use those programs, those scripts that I've developed for only specific views. Yeah. And third, adding colors to the clashing elements to differentiate, which is the concept that came from Navisworks. So I just want to apply the same the same visualization that I've seen from Nevis work to Revit. So it will be easier for modelers to use that. And lastly, it can be run through a click, which is using a UI through a Dynamo player. Yeah, next. So what we can achieve from this is, yes, being more productive, and secondly, you can speed up the process. So if a modeler like me or my colleagues would like to submit their work in a proper manner without having any clashing problems or interference problems, then this is really good enough for you to run this script and find whatever modelers that they model in place, and yeah, this would speed up the process. Next. So here's the video that shows how does this Dynamo player works. As you can see, there's two categories that you guys can select. For this case, I select ducts and pipes, and yeah, those 3D views are generated according to each and individual clashes. So from there, if you're able to identify, right, you just amend the clash, and yeah, to improvise this thing, right, I thought of adding a parameter, which is let the BIM modelers to BIM coordinators to let them know that this problem has been resolved and for your checking. So when BIM coordinators knew that those are already resolved, then they can just delete those 3D views. Yeah. Next. And yeah, thank you for the presentation.
Thank you. Thanks, David. Yeah, I think for Boustead part today, we have come to the end of presentation. For any Q&A or question and answer, we will answer it later. Thank you so much, everyone, for listening to us. Next, we'd like to invite Ken from Autodesk. Ken, you ready to show this present?
Yes. Okay.
Thank you,
Share
Ken.
my screen.
Thanks.
Okay. Can you guys see my screen?
Not yet.
Wait a minute.
Sure.
Okay. Okay. Is it okay?
It's dark now.
Okay. Okay. Wait a minute.
Sure. Yes, now we can.
Okay.
Thank you, Ken. Go ahead.
Okay. Yeah. Good afternoon, everyone. Thank you for joining us in BCA Computational BIM webinar today. My name is Phuc or Ken. I'm a technical specialist at Autodesk and based in Ho Chi Minh City. It's my honor to be here to talk about the session solar analysis calculating shaded area in Revit for sustainable design. Okay, let me start with the session description. Sometimes when planning building areas, you may want to identify what a building shadow looks like. In some case, you want to determine how shaded exterior walls, windows, or shading device will be. One option to get this information is using the solar analysis tool included in inside plugin in Revit software, and we will also show the advanced processes using Dynamo and Revit API to determine the physical shape of shadow and the shaded area of a whole building or a particular object in Revit models. And this session provides a basis for using BIM models for the design and analysis of sustainable buildings. Apart from the main content of shaded area calculation, I will have a brief introduction of all the information related to solar studies, and I hope you guys will enjoy it. As you also know, sun is an essential and important source of renewable energy. It frees and has a huge potential. Many research found that the annual potential of solar energy is several times larger than the total world energy consumption. We have two main types of solar energy technology. Those are the first is active solar techniques include the use of photovoltaic system, concentrated solar power, and solar water heating to harness the energy. And the second is passive solar techniques. Including the orienting a building to the sun, selected the material with favorable thermal mass or light dispersing properties, and design in space that natural circulate air. And here are some key factors when studying solar energy. First, you need to concern about the building orientation and building trace. Orientation is simply what compass direction the building face. This orientation lets you consistently harness the daylight and control glare along the long face of the building. It also lets you minimize glare from the rising or setting sun. And for that design, we will talk about it later. One thing to consider is material, such as the insulation, absorber, thermal mass, and distribution. And another important thing to study is the sun pass at your location. And do you know for important days to study the sun pass? Here's some tips for you. You need to study in a particular days. For example, in the solstice, to study the extreme of the sun position, or the equinox to study average sun position. And you need to study in different seasons. In winter study to know how can you maximize the sun to passively heat the building. And in the summer studies, how can you minimize the sun to passively cool the building. And next, I will show you how can red solar energy study through Autodesk technology. First, if you are not ready using Revit to support sustainable design in your design, you should be. Data and collaboration are now at the forefront of driving green performance. Architect and engineer are equipped with various data and collaboration tools to help them achieve sustainability goals, one of which is Autodesk Revit. And I'm sure all of you know the power of Revit in building models and data. Secondly, Insight tool is an in-beam building energy tool. It's work directly inside Revit and form it Pro using the existing beam model, so you don't need to create the outside model of the beam workflow and no throwaway beam model with Insight. Revit and Insight offer a true real-time feedback to visualize and interact with key performance indicator, benchmark, factor, ranger, and specification. And this tool has highlight accurate. They run 100 of simulation in parallel to ensure accuracy, and it's been well proven in the field. And with Inside with e-builds into Revit, and from IT Pro, architect can model and simulate multiple options early and throughout the design process, making it easier to for an architect to do simulation and evaluation option before too much is baked into the final plan. So by using this tool that we will go through in this session, you can increase productivity, save time and efforts on conduct detailed design analysis, and ensure you are meeting your client's needs. We have two subtopics will be discussed. First, about the PV energy of the solar photovoltaics, and second is the shading design. Now just quickly show how to set up the Revit model for solar analysis. First, you need to prepare your model and select the 3D view. You want to study the sun analysis, and in the view control bar here, you can see the sun icon and the shadow icon here. And first, you need to set up the sun setting click in the sun button, select the sun setting, it will appear the dialogs about the sun setting, and you can choose the solar study as you want, and then verify the location, then click OK and turn on the sun pass in here. And finally, to know the shadow, just turn on the shadow in the Revit 3D view to visualize, and you can easily change the date. For example, I want to change to September, and as well as change the time. Yeah, so you can see different sun location and is how it impacts to the building. Now let's talk about the Insight tool. The Insight solar analysis with Revit provide it. You can find it in the analyze panel, and in this tab energy analysis controller. And if you want using this plugin, you can visit this website to download the plugin for each version of Revit, and you can download for the Revit 2016 to 2020, and for Revit 27 2021 solar analysis and lighting analysis are available, and you can download it in your account of Autodesk. This is a general workflow for evaluating the PV potential of the solar photovoltaic of a building in Revit and Insight. First, you need to verify the project location and sun setting in your model. Then prepare the 3D view for analysis. You need to define the study time and the sun phase. For example, you want to use the roof of the building, or want to use on the walls and roof of the building, and then using the solar solar function in the energy analysis tool, it will simulate for the determining the PV energy production estimate. For example, in this case, the result will show you the PV energy production is around 493 kilowatt hour per year if you use on roof of the building as solar energy, and the result can extract to the Excel to publish to the Insight web page to help you easily visualize on the web browser. And another workflow for determining the solar assets. Solar asset is a great way to determine if a space is achieve enough daylight throughout the day, and also to refer to as the daylight assets. Many countries and regions are now requiring new building meet the specific solar asset standard, such as SEPP 65 in Australia. The workflow is similar with the previous workflow. You need to verify the project location and define room in your Revit model. Then using the lighting tool to set the lighting study setting with the solar asset with the rule you setting. For example, in this case, I want to set the rain time range from 8 a.m. To 4 p.m. and I want to know how many rooms I have minimum 3 hours can achieve the daylight, and the tool will generate and simulate the solar assets in the cloud, and it will send you the result at the table here. For example, in this case, I have the 45%, 44% of room past the request. It means we have around 44% of room had more than or equal 3 hours get the direct sunlight, and we had 47% of room have 0 hour to get the sunlight directly in the room. And you can visualize the solar analysis result in any plans, in any 3D views, and in your Revit schedule. And as mentioned earlier, and the performing solar analysis also consider the shading design. Shading should be considered as an integral part of penetration system design for building in order to balance the daylighting requirement versus the needs of reduce the solar gains. Designers are facing two challenges in shading design with the goal to control the instant direct sunlight to ensure a comfortable space. Uh, we need to design the shading device because the shading device can play an important role in improving the energy efficiency of the building. And you can see a common shading strategy in this image with different form or different type of shading device will have different impact to on the getting the sunlight of the building. And one more interesting, I will talk about it soon, is the using the adaptive shades in the models. Second challenge is determine the shadow and calculating the each shaded area. Some country, for example, in Singapore, we have the ETTV calculation or envelope thermal transfer value calculation for the building design to identify the shading coefficient of the sun shading device. And we have more and more building shadow study to its neighboring the area. This is an example of an adaptive shading device with Dynamo. The shade depth of the shade overhang and number of shades of a window family are automatically generated to completely shade the window vertical depending on the input variables. For example, the window height, window width, the max shade overhang, and the sun position. Here is the simple video of adaptive shade. I have the window family with the overhang shade in a simple building. And this window family, I have some type parameters such as height, width, overhang, and you can see the shade overhang completely shade the window with this solar position. And I use a Dynamo strip and with some inputs here. And if you can see, if I change the window height by increasing its value, the Revit family will automatically adjust. And when one shade is not enough to cover the window, it will divide into two shades and then adjust the overhang of the shades. And if I change or if the position of the sun changing, it means the angle of the sun change, the depth of the overhang of the window will automatically adjust to. Yeah, and you can see at any day time of years, the shade overhang will completely shade the window with the sun position. So with this Dynamo strip, you can use a 3D visual presentation option and relevant shading device. The designer can check the appropriate shading design in a different daytime or year. And so with Revit or any BIM 3 models, BIM tool, we can visualize the shadows in the sun studies. But all of you know, the shadow here is not a real element, just a presentation purpose, just for the presentation. The next question, I guess, is how to determine the physical shape of the shadow and calculate its area at any daytime or any sun position. at any location of the building. For example, we have a lot of problem with to calculate or to visual the shadow of the building as a real element in Revit, or how to calculate the shaded area of the window by the shading device. And the following thing I will share with you is the answer. We extend the Revit capability with the power of Dynamo. In the previous session, you can see the power of Dynamo in digital design documentation. And now Dynamo is the visual programming for computational design. Dynamo help you explore the graph without coding and help you flexible to switch the variable need. And one of the most exciting things about Dynamo is its ability to set up a feedback and response scenario between the building components. And this is the simple workflow, or just a basic simple workflow to calculate the shaded area and show the physical shape of the shadow on the window. First, I need to get the window and its shading device, and you can check the sun direction if needed, because sometimes the sun direction is opposite with the window direction, so it means no shadow at that time. And after you get the shading device, you need to capture its geometry and get this edges, and then you project each edge of the shadow, the shade, onto the plane of the window by the sun direction. And after that, you join on receive curve from projection to retrieve the whole shadow on the plane. And finally, we intersect to get the shadow on the windows and display it and calculate its area. And based on the workflows, here a simple Dynamo graph to calculate the shadow of a building on the graph. I have three inputs here. The first is the mass of the building. Second input is the graph floor. And the third input is the sun direction of the current view. Based on the mass of the building, I can get its geometry, the surface, and the curve, everything. And then I use the node called surface.project to project an input geometry onto a given surface. Is a graph floor along a given direction, is the sun direction. And I will get the receipt curve after this position, and use the nodes polycurve dot join curve and surface by path to create a surface by filling in the interior of a closed boundary defined by input curve. And then using the node direct shape by dot by geometry to create the real elements in Revit represent the physical shape of the shadow and easily to calculate its area. And the following video will show will help you have a better look at the workflow I just mentioned. This is the demo video to calculate the shadow of the building. I have the building in Revit, and if as you can see, if I change the daytime, the shadow will change directly. But the shadow here is not a real element. It just for the presentation purpose, and you cannot capture it and cannot calculate it areas if we just without Dynamo. And I use the Dynamo player to run my script. I have two input here. Select the mass of the building, and the other input is select the graph floor to capture its shadow. and just quickly run the button, and we just a moment we can see the result. It will display a real element in the Revit model. This real element represent the shadow of the building, and it also have the property about the shaded area. And you can see in the property here we have the area of the shadow at that time. Yeah. And one advantage of Dynamo is you can easily adjust the input. Adjust it mean in this case I can easily change the daytime and can just click the run button again, and it will show the shadow at the new daytime. And the real element of the real physical shape of the shadow is correctly meshed with the shadow in the Revit environment. And another video is using Dynamo for shaded area calculation of the window. This is a simple building. I have multiple windows with multiple shading device. We have the horizontal shading device, vertical shading device, parallel shading device, or edge shading device, and even a complex or organic shading device. Um, and we can use Dynamo to run a script to show the physical shape of shadow as well as its area. In this Dynamo script, I have two inputs. The first is the shading device, and the second is the window. You want to calculate its shaded area. And just a moment when click run in the button, you will have the real element represent the shadow of the shading device on this window, and you can easily repeat the procedure with different window and different shading device. Yeah, and you can see the shadow here matching with the shadow we can visualize in the Revit 3D view. Yeah, as you can see in the last two demo videos, Dynamo can have the basic calculation on shaded areas. However, if we use Dynamo to perform the shaded area calculation for entire building or large building, it would be very time consuming task. Therefore, we need an advanced solution here, and this is Revit API. API is stand for Application Programming Interface, and Autodesk Revit provide a rich and powerful .NET API to unlock the full power to the coder and the end user. And based on the Revit API, we can build an add-in to calculate the shadow area for the host building. And this is a demo video of using sample Revit add-ins for shaded area calculation. The original video lasts 15 minutes, and but to fit the time of this session, I just show the result of the demo, and you can watch the full video at the link in the QR code in the right corner here. And in this demo, I calculate the shadow areas on Windows with the time frame, and that is set from 7 a.m. to 5 p.m. And after running the add-in in Revit, we can see a lot of shadow element. It's the real shadow physical element. It represent the physical shape of the shadow in different daytime on each window, and we can see the value of the the value of the shaded area based on the time frame. And the time frame I set from 7 a.m. to 5 p.m. is mean each parameter will include 10 values of the shaded area at that time. And this result will help us observe the different shapes during the daytime and extract the maximum minimum the average value of shaded area accordingly. And next step, the calculated shader calculated area can be scheduled and reported, and this will aid the design process in later stage. For example, to calculate the ETTV value of the room for sustainable design. That's conclude my presentation, and I would like to quickly summarize the main points or takeaway. First, you learn how to set up the Revit models for solar analysis, and next you can discover the Insight plugin for Revit and learn how to use the solar analysis tool. And then we learn how to calculate the shadow areas in model and show the physical shape of the shadow with the power of Dynamo and Revit API. And finally, we understand how to use Revit to design and make a sustainable building. And so we can do more with better outcomes and less impact to nature. That's brings us to the end of my presentation, and thank you so much for your interest and attention. And if you want to find more information such as the dataset, the demo, the simple demo script, the tutorial video of this session, you can access my class at AU 2020 at the link in the QR code here. Just let you know, AU is Autodesk University, and this year's is our first ever global digital conference with no cost to attend. And on the dataset and video of my class in AU 2020 will be available when it's kicked off that week. And again, I'd like to thank everyone for your time today. And now I will over to Khalil with the Q&A session. Thank you.
Thank you, Ken. Thanks for the great presentation. It was very informative. Yep, I think now we have ended early. We have some time, so I would like to invite Mr. Pong from BCA, to say a few words before we deep dive into some of the Q&A. I think there are some questions in the chat messages which we can, later direct to those individual questions to the responsible people. So, Mr. Pong, maybe you'd like to share your thoughts on how things have been going in this sharing session.
Yeah, I think thank you everyone. So thank you for hosting this session, Khalil, and especially the speakers as well from Weijenberg and Autodesk, and yeah, also for this event to happen for everyone that attends. So I think this session will be recorded as well, right? So if anyone who missed it, maybe you can visit the computation.space later. So let's actually let's move on to the discussion. So yeah,
Thanks.
thank you.
Thank you, Mr. Pong. Okay, right. Let's deep dive into the Q&A. Anyone here, you guys are free to unmute yourself if you have any question. Weijenberg, the first presenter, and then Boustead, and then we have Autodesk, Ken from Autodesk. If not, I'll start with the one that is on the message here. Maybe I start with the first question. Okay, there's a question from Chan. I believe this is directed to Boustead with regards to the Dynamo. Is it working in link MEP files? Maybe I get Harmeet or David to answer this from Boustead.
Hi, Khalil. Harmeet
hi.
here. Okay. To answer Mr. Chan's question, we did try it in terms of link files, but we are facing a bit issue because especially if both the files are linked, then the problem comes where we need to create filters for that. So it works well when one of the file is in the host, one of the elements that is required in the class is in the host and the other is in the link. But yes, we are trying our best to fix all the problem, and I believe working with David, we are coming up with a good solution on how to work with link M&E files. So maybe in the near future, we'll definitely have solved all those issues where we can come up with a clearer clash report on M&E.
Okay, thanks, Hamid. So I believe what you're trying to say, I think Chan also just left the meeting, but what you're trying to say that currently it's not working yet, but there is an effort to go move a solution to find a solution to that. Okay, thanks. I move on to the next question. So Weijenberg, hope you are still here. Cool presentation from Jack Lee actually. Do you foresee digital blue form or DBF being used as the tool from concept to detailed design? I suppose there is automation. It becomes much easier for architects to simulate, but it also reduces control compared to traditionally drawing the lines one by one. So the question is, would you develop DBS, in this case digital blue form, into a tool for detailed design to automate plans and tender drawings? Thanks, from Jack. So anyone from Weijenberg or Camiel, are you still around, Camiel? Would you like to answer this particular question? Hi, Camiel, you there? Okay, I think maybe he's not around, but I saw his name. It's okay, let's move on. Anyone else got any question? Q&A. Let's share the screen. Yep. Anyone else got any question before we go on to TGIF? Oh, this wants to join. Give me a second. Okay. Yeah, it seems there's no more question. I believe every one of us here just want to enjoy the Friday, it seems, you know. Okay, if not, yes.
I have one question actually to the floor. Actually,
Go ahead.
For anyone who would like to present, I mean, their experience and use cases, maybe you can email me, drop me an email. Yeah, thank you, and we hope that this community can keep on going. Yeah, so thank you very much for the support.
Thank you, Pong. I think I really appreciate that you invited Boustead and then some of the speakers today. I think it's been a pleasure. giving us this opportunity to share what we know, and then I hope it gather more traction in the industry itself for us in terms of computational.
Yes, yes. Thank you. Yeah.
Thanks. All right. I think there's no more question. It's time to do the Friday dance, I guess. And again, I really hope everybody who attended this session today gained some knowledge. The key takeaway here, what I see, there are some traction, the use of Dynamo. And then also in terms of fabrication, we see beautiful design. It become more productive for us in that sense. So again, thank you so much. Thank you everyone for your time. TGIF. Bye-bye.
Thank you. Bye-bye.
Bye-bye.